Hi, my name is NURUL NATASYA binti TAJUDIN. So today I will be presenting the key insight from a title Thermal and Spectroscopic Profile Variation of Core Raspberry SITI by DSC, UV visible and FTiR techniques. To begin, let's establish the context of our study. It's truly fascinating to see how the market for Raspberry has expanded globally. In fact, the raspberry production in Europe Union was reported to increase up to 45% in gross production value during the last 10 years. Next, after raspberry are processed, there's a substantial amount of byproduct, primarily pomace and seed. What is exciting that these byproducts are valuable due to their chemical composition and nutritional content, making them suitable for use as nutritional supplement, cosmetic, and food additive. Now let's focus on one of the most promising byproduct, which is the oil from raspberry seed. We have found that it has contained a high percentage of oil, with yield potentially reaching 2 to 3% depending on the extraction method. This resulting that compressed raspberry seed oil as a niche product commanding a high market prices. Given the value and interest in raspberry seed oil, ensuring its quality and authenticity is paramount. This is where advanced analytical tools come into the play. For instance, DSC is able to map the fingerprint spectrum based on oil and fat thermal behavior. Simultaneously, FTiR is utilized to investigate the quality deterioration of oil by tracking the absorption changes. Critically, both of these methods are fast, chemical-free, non-destructive, and reliable, which makes them suitable for rapid authenticity monitoring. So, they provide us with powerful, efficient ways to assess oil quality directly. Moving on the core purpose of our research, the study had a clear aim from the start. Firstly, it aimed to investigate the characteristics of 6 cold-pressed raspberry seed oil, including the fatty acid composition. This was important for building comprehensive profile of the specific oil sample. To achieve this, our methodology involved in-depth analysis. We also conducted the melting and crystallization phase transition analysis. This allows us to understand the thermal and spectral fingerprint of the oil. Specifically, we focus on 2 groups of oil samples, which is commercial oil group and laboratory pressed oil group, which was the key to comparing what's on the market with freshly prepared sample. All of this using DSC, UV visible and FTiR spectra.
The spectral range is 4000 until 500 wave number at 4 cm -1 resolution in reflected mode. The background measurement is the spectrum of the clean diamond crystal surface was recorded. This background spectrum was used for correction, subtracting any absorbance from the AFIQAH crystal itself. For the sample preparation and application, approximately 50 microliter of raspberry seed oil was used for each measurement. The oil was uniformly dropped onto the surface of the AFIQAH crystal. Measurement condition. Analysis was carried out at room temperature. Spectra were recorded 2 times for each sample to ensure reproducibility. Cleaning procedure. The outer surface of the FTiR crystal was cleaned with ethanol after each equation to prevent contamination between samples.
Next, I will explain the results in the study paper. This video only focuses on the result obtained from FTiR spectra, so I will only explain on the area. The study mentioned that FTiR spectra revealed important differences between commercial and laboratory pressed raspberry seed oils. This means that the chemical composition of these two types of oils are not the same. The FTiR spectra indicate the presence of various functional groups, characteristics of fatty acid and triacylglycerol. Notable groups included CH3, CH2, C double bond O, OH, and cis and trans structure of carbon double bond. A significant correlation was observed between the unsaturated fatty acid to saturated fatty acid ratio calculated from fatty acid composition and the peak ratio of 3011 and 209,025 wave number. This ratio served as a good measure of the presence of unsaturated fatty acids in the oil. The band at 1712 wave number was identified as an important parameter that quantitatively expressed the presence of free fatty acids in the sample. Additionally, the position of this band indicated the presence of acyl groups. The band at 966 wave number linked to the presence of trans double bonds, and at 721 wave number related to cis double bonds. These are crucial for assessing the quality and potential adulteration of the oils.
Hello everyone, welcome to the discussion part, and my name is NURIN AFIQAH. I will be the guide to elaborate you guys more about FTiR for this article. So stay tuned. Regarding this article, the FTiR spectra of raspberry seed oil were measured within the range of 4,000 to 500 per centimeter. It is focusing on the presence of various functional groups characteristic for fatty acid. The Heinz value of glycerol was calculated by a number of CH2, mg/kOH per gram oil, cis and trans structures, while the lowest C double bond is 3.71 mg/kOH per gram oil, allowed for the identification of specific bands associated with different compounds, such as free fatty acid and unsaturated fatty acid. A study demonstrated that FTiR can effectively differentiate oils based on the quality. For example, the presence of alkyl group of linoleic and alpha-linoleic acids was used to assess oil quality. The study demonstrated that FTiR can effectively differentiate Another important bands that are used to analyze the oil's quality are linked to the presence of trans double bonds and cis double bonds, because when these two is exposed to excessive heat or oxidation, the cis-trans isomerization may occur, which is manifested by the disappearance of double bonds in cis conform. We can evaluate the composition of the oil that is obtained, especially in terms of its oxidation and the ratio of unsaturated fatty acid to saturated fatty acid. A good measure of unsaturated fatty acids was calculated, and it expressed the presence of CH bonds involved in the cis C double bond C bond. The presence of unsaturated fatty acids based on the peak ratio were calculated and shown in the table next to me. The FTiR analysis also indicated the potential oxidation in the oils. For example, the presence of peak associated with hydroperoxides suggested that some of the samples might have undergone oxidation, which can affect the oil's quality and shelf life. Based from the data from the article, the industrial group spectra exhibit a peak of hydroperoxide at 987 per centimeter, while laboratory group missed the band in the spectra. However, there is the band at 966 per centimeter indicated as the presence of the trans-unsaturated fatty acid in laboratory group. Small differences observed might have been caused by the initial conditions of the seeds. For example, the seeds are in fact a byproduct, and the process of preparing seeds for the pressing will take a longer time. Therefore, the seeds are never completely fresh. Small differences. Other than that, lower content of trans-conjugated dianic compound and lower free fatty acids content may indicate the partial refining process of oil. Laboratory group oils have higher adsorbent, which is around 3470 per centimeter, correspond to the presence of the hydroxyl group due to the moisture in the oil. Based on the FTiR spectra, the PCA method was able to differentiate the samples into three clusters. The first cluster consists of L group followed by two I group, which is I1 and I2, and lastly the outlier, which is I3. We need to analyze the analyte from the sample because it is essential for determining its nutritional quality, which is it helps in assessing the health benefits associated with the oil. Other than that, it helps in identifying any oxidative changes in the oil. It is to maintain the product standards and ensuring the customer safety. Lastly, it provides insight into the variability among different oil samples because it is important to understand the variations in quality and potential applications. Lastly, the FTIR technique was chosen because it proved to be a very powerful tool for analyzing the quality and the composition of cold-pressed raspberry seed oils. Lastly, the FTIR technique has the ability to provide the detailed information on fatty acid profiles and potential quality indicators.
FTiR spectra were instrumental in detecting a difference in the ratio of unsaturated fatty acid (SFA) between the L group and I group raspberry seed oil. This finding was further confirmed by independent fatty acid analysis, reinforcing the reliability of FTiR for this purpose. Quality differentiation based on free fatty acid. FTiR demonstrates its utility in differentiating oil quality based on the presence of free fatty acid. Specific spectral band assigned to FFA allow for this differentiation. This was further validated by direct measurement of the acid value, confirming the correlation between the FTiR signal and FFA content. Contribution to overall clustering. The variation observed in FTiR spectra were a key factor enabling the distinction of the sample into two distinct clusters, L group and I group oils. This study highlights FTiR as a useful instrumental method for assessing the quality and potency of raspberry seed.